All right, if you haven't already, go watch that first video I posted. It's slightly different from the direction that we're heading with this one. Okay, this is another example of quadratics in using projectile motion. And so we're going to go ahead and use this situation here. A golf ball is hit from a platform that is 95 feet high with an initial velocity of 88 feet per second. Okay, so certain information is given to us. Okay, and what we're going to do is we want to know when will the golf ball be at a height of 175 feet. All right, so let's go ahead and identify some of the information given to us over here. Okay, so notice that it's hit from a platform that is 95 feet high, which this would indicate that it is an initial height. Okay, and notice that I have an initial velocity of 88 feet per second. The units right after denote what I'm going to go ahead and use for each one of these. So if I look at my function h of t, height with respect to time, it's equal to negative 16 t squared. My initial velocity is 88 feet per second. It's going to be plus 88 t plus 95. Okay, plus 95. And so what we're going to go ahead and do is we're going to go ahead and um, what we're going to go ahead and do is we're going to go ahead and use this function for height to figure out when it will be 175 feet high in the air. So if I were to draw a picture of this, this would look something like this. Okay, so let's say this right here is our axis. This is t, which represents time. This right here is h of t, which represents height. And so here we have this platform, and we have this golfer here. He's about to hit the golf ball, or he actually just hit it, and it had an initial velocity right here. It hit the ground, right? Now this right here is 95 feet, and I want to figure out when it will be at 175. So 175, let's um, let's go ahead and let's leave that um, for different time, right? So not for different time, but um, let's say 175. We'll say 175 is right here somewhere, right? I want to find out what these times are now. So I want to find out what those times are. Now I can go about. I want to go ahead and use this function of height with respect to time. Okay, and I want to find out when this right here is going to equal that right over there. Okay, and so what I'm going to go ahead and do is I want to go ahead and set my quadratic function equal to 175 feet. So negative 16 t squared plus 88 t plus 95. I want to know when that is going to equal 175 feet. Okay. I could have done without the units for now. Without the units for now. Okay. So I want to know when it's going to equal 175. All right. So just like the previous one, I want to move all of my terms to the right. Okay. To the right side of my equation because of this leading coefficient right here that's negative. I want to make sure that it's easier to work with positives, right? So I'm going to go ahead and zero out. Oh, this should be a minus 95. Zero out all of these here. Okay, so it's going to be plus 16t squared minus 88t minus 95. And notice that the 75 or 175 and the minus 95 can combine. So this right here will be 0 equal to 16t squared minus 88t minus, this is actually plus 80. Sorry, plus 80. Plus 80. So now that I have this here, what I'm going to go ahead and do is I'm going to go ahead and see if I can factor out a GCF, right? So in this case here, I can factor out my GCF, which in this case here is going to be 8. All right, so I'm going to go ahead and factor out my GCF. So this is going to be equal to 8 times 2t squared minus 11t plus 10. Right, now that I have that there, what I can go ahead and do is I can go ahead and I want to get rid of this coefficient here. So what I'm going to go ahead and do is I'm going to go ahead and divide both sides by 8. Okay, divide both sides by 8. Divide both sides by 8. Okay, so let's go ahead and let's do that. I'm going to divide both sides by 8. So I'm going to divide this here by 8. Divide that by 8. These cancel, right? Those are equal to 1. And 0 divided by 8 is just 0. So 0 is equal to 2t squared minus 11t plus 10. I didn't need that parentheses there. Okay. So now that I have that there, I can't necessarily factor that, right? I don't have any more GCFs I can factor. And so what I'm going to go ahead and do is I'm going to go ahead and I'm going to use my quadratic formula. In this case here, a is equal to 2, b is equal to negative 11, and c is equal to 10. Okay, so I'm going to go ahead and use a quadratic formula to solve for t. So t is going to be equal, normally we use x, but in this case we're trying to find the time, right? T is equal to the opposite of negative 11. Notice that I'm using parentheses wherever a variable goes, plus or minus the square root of negative 11 squared minus 4 times a times c, which is 10. Right, close that up, all over 2 times 2. Okay, and after you simplify the discriminant, right, this is the discriminant right in here. Okay, we get that t is equal to 11 plus or minus the square root of 41 all over 4. So t is equal to 11 plus root 41 over 4, or t is equal to 11 minus root 41 over 4. Now, if you enter this into your handy dandy calculator, okay, um, let me see if I can include, oh, let me see if I can include my calculator with this one. Okay, if you enter those into the calculator, we get that that right there is going to be 11 plus root 41. All of this right here, I'm going to go ahead and put in parentheses, all that divided by 4. Okay, that's one of them. Okay, so I'm going to go ahead and just use this right here. 11 minus root 41 all over 4. So notice that we have all these decimals. I want you to round to the nearest hundredth. All right, so going back over here, we get that t is approximately, and we use these squiggly equal signs, right? 4.35, or t is approximately 1.1, 1.15. All right, so I'm going to use a sentence. The golf ball reaches the height of 175 feet after 1.15 seconds and 4.35 seconds. All right. Oh, let me move it up a little bit. So once you calculate it, you should be able to find the times. All right. Now let's go ahead. Let's look at a different situation. All right. Using this same idea, I want to figure out when the ball, if it will ever reach 250 feet. Okay, I wanted to know if it will ever reach 250 feet. So let me go ahead and get a clean sheet of paper. All right. So this is B. Excuse me. Will the ball ever reach 250 feet? If so, when will it reach that height? Okay. So now what I want to do is I want to know if it'll reach 250 feet. Okay. 250 feet. So let's go ahead. Let's take a look at our function. So our original function is negative 16t squared plus 88t plus 95. I want to know if it'll ever reach 250 feet. Okay. So what I'm going to go ahead and do is I'm going to move all of my terms to the right side of my equation so that I have um, a positive leading coefficient. So let's go ahead and let's do that. Plus 16t squared minus 88t minus 95. I'm going to go ahead and do that the same thing right over here. 88t minus 95. These cancel, that those all three of those make a 0, right? 0 is equal to 16t squared minus 88t minus 95. Sorry, it should be plus 155. Let's rewrite that. 16t squared minus 88t plus 155. Because 250 subtract 95 is 155. Now that we have that there, I'm going to check to see if I have a GCF. I don't have a GCF. The GCF for these three terms is 1, right? 1 divides 16t squared, 1 divides negative 88t, and 1 divides 155. If you're not sure how to find the GCF, you can do the prime factorization just like we've done before, and you can factor that out. So I'm going to go ahead and use the quadratic formula. A is equal to 16, B is equal to negative 88, and C is equal to 155. Okay, so what I'm going to go ahead and do is I'm going to go ahead and use a quadratic formula. T is equal to the opposite of B, which is negative 88, plus or minus the square root of negative 88 squared minus 4 times 16 times 155. Let me extend my square root. All over 2 times 16. If you simplify this here, we get that this t is equal to 88 plus or minus the square root of negative 2,176 all over 32. Now, one thing I want you to note that the discriminant is negative. And if we looked at the previous lessons, right, we know that if the discriminant is negative, then that means that we're not going to have any real solutions. And we're talking about a golf ball in the air, right? So in real life situations, we cannot have complex answers, we cannot have complex roots. So in this case here, the golf ball will never reach 250 feet, right? So we can say the golf ball will never reach 250 feet. And I don't have to do any more work besides that, right? It'll never reach 250 feet. So I think the problem that a lot of us may have will be identifying what the initial velocity and the height is. Just look for the units, right? If it's saying, for example, in the very beginning, where we're talking about the golf ball that is launched from a platform, right? That's 95 feet high. Notice that it's just 95 feet. It only includes the feet. So that is an initial height, and it gives you the initial velocity as well of 88 feet per second. Once you set up your function, then just take a look at what the question's asking you. Okay. If you have any questions, feel free to email me. I am available through email, so be sure to do that.